Hi everyone, this is the introduction lecture to engineering economics. If you haven't already gotten a chance to review the syllabus and all the class information, you can go watch the course outline video or read it all from the Colab site. I suggest you start with that before you get started with this. Today we're going to discuss what engineering economics is and why it is going to be relevant to your career in engineering. Let's start with some characteristics of engineering projects. They have some unique characteristics that make this class necessary. They generally have high costs, they take a long time to complete, and they are often very complex. There is also uncertainty regarding details of the project in the long term, and as well as economic conditions in the long term, so inflation rates or the ability to finance the project. So we're going to look at some examples of projects that you probably know of. Start with John Paul Jones Arena, our basketball stadium. That project cost $131 million and took 2.5 years to build. It opened in 2006 and it's likely going to be used for a very, very long time. So that's some costs associated with the project are going to be operating and maintaining it. There was obviously the construction cost and the cost to contract all the work out. And then, they also have income for concessions and everything, and ticket sales and TV deals, etc. So it's a complex project with tons of cash flows, and it had to be justified in building before UVA could move forward with the project. Another project, you probably noticed that the rotunda is usually under construction. This is the second phase of the rotunda restoration. That project was estimated to be $42.5 million, and it's been going on a while. So now we can look at some projects. This was a study by the Washington State Department of Transportation, and it shows project costs for some of the more high-profile roads in the state of Washington. You can see there's a ton of variation in the cost per lane mile as well as the total cost of the project. For example, the North Spokane Freeway, you can see, has $167 million per lane mile. It's 167 lane miles, but it's fairly cheap. Also, you can see the Alaskan Way Viaduct and seawall cost $180 to $267 million, but the cost per lane mile was a little cheaper. So each project, you can't really transfer one aspect of a project over to another one and assume it's going to be the same. Now we're going to take a look at some high occupancy toll lanes on 495 in Northern Virginia. So for those unfamiliar with the concept, these are high occupancy vehicle lanes, but they also allow single drivers to pay to use them with a guaranteed travel time. So, as with most toll roads, this project was sent to the private sector to carry out, and the bidders were going to be responsible for all aspects of the project. This includes design, build, operation, maintenance, and financing. This project had an estimated cost of $2 billion, and as a business interested in bidding on the contract, they need to decide if they can recoup the $2 billion and earn money over the huge life of the project, with great uncertainty very far into the future. If you think 100 years ago what roads were like, compare them to now, I'm sure some of the assumptions that people made back in the day were off. So, same for now. We're projecting 100 years into the future. We don't really know what our situation's going to be like. But they need to try and guess what the state of the economy is as well as their ability to continually make money. So that goes through some examples. I encourage you to look at more in your free time if you have some. We're going to start by looking at the principles of engineering economics now. There are 7 of them outlined in Chapter 1 of the book. They are to develop alternatives, focus on differences, use a consistent viewpoint, use a common unit of measure, consider all relevant criteria, make risk and uncertainty explicit, and finally to revisit decisions. So the purpose of these is to try and simplify a very complex project into something that allows us to tackle the problem and make a good decision in a manner that makes sense. So now we are going to talk about each of these a little bit more in depth. So when we talk about developing alternatives, we mean an alternative is a possible project that meets the needs defined in the project scope or the request for a proposal. So remember, engineering projects are always going to be multi-objective in that they need to properly address safety, performance, as well as the costs that we're considering. And we are mostly just focusing on costs in this class. So the problem should be carefully defined, and then a set of feasible solutions that address the problem should be devised for additional analysis. So now if we want to focus on the differences, this is important because you have to keep in mind that if 2 alternatives have common attributes, those attributes will need to be paid for or will be present in the project regardless of which alternative you select. So focusing on similar things in 2 projects doesn't make very much sense. Using consistent viewpoint means that alternatives need to be evaluated from the same point of view. So costs and benefits are not going to be the same for everyone, so typically the decision maker's viewpoint is used, but some stakeholders have different interests than others. Whoever's paying for the project obviously cares a lot about the money in addition to its usefulness, but the users of the project, so if it's a road, they care about it being operationally efficient and safe. So everyone has all these different viewpoints, and you need to make sure that you are comparing your projects from the same viewpoint. A common unit of measure ensures that projects can be compared directly and fairly. For this class, that unit is going to be the dollar, since we are focusing on the economic side. Translating benefits into dollars can become very complex and often requires some assumptions, and it gets even more difficult when you consider that some of those assumptions need to try and monetize ethical, social, or religious benefits to projects when those are obviously sometimes priceless. So considering all relevant criteria is critical to estimating the true cost of the project. This is going to include everything that goes on into project planning in the short term and the long term, and figuring out what the consequences are of selecting an alternative. Making risk and uncertainty explicit. This is one of the more important concepts in this class. Uncertainty is a massive, massive part of engineering projects. So we try to take the information that we have and make reasonable assumptions so we can get somewhere and try and make a decision, and we're not just waiting. But part of carrying out these projects and doing your analysis is understanding where you're making assumptions, how likely or unlikely those assumptions are to become true. So you have to analyze the risk of that assumption not being true, being partially true. And you need to conduct sensitivity analysis, because that is going to help you make a decision when you realize that some assumptions when they're off, you have to figure out what is going to happen to the value of your project. So this will be a recurring theme, and you'll need to remember that uncertainty is important to outline at all times, and make sure that you're considering it and documenting where you're making these assumptions. So finally, the last one is to revisit your decisions, understanding how everything turns out relative to the projections. This will help with the decision-making process in the future, so you can go back, figure out what you did, see where your assumptions were true, see where they were false, and maybe help you make a more educated guess in future projects. So, why do you personally need to know engineering economics? Engineering firms, the government, everyone who does engineering, civil engineering at least, uses this in every aspect of what they do. So this includes bidding for projects. So when you want a project, or your company wants a project, they need to submit a bid, and there's an economic analysis period where you need to figure out how you want to submit the bid and if it's worth submitting the bid. For planning projects, financing and operating infrastructure, and literally everything else that they will do. So the knowledge gained from this class will be important to understand the decision-making process firms go through. Even if you don't carry out the analysis yourself, the results will directly impact your work. So being at least peripherally familiar with this is a key part of your education. And if that is not enough, the concepts in this class are essential and will be on the FE exam, which many of you will take if you want to work in civil engineering. So the FE exam is the fundamentals of engineering exam and earns you your engineering and training license. So this class will help prepare you for that. That's it for today. Thank you very much, and we'll talk to you next week.